My name is Almiray. I come from Mexico, but I work for this company called Canoe. It's a Swiss company, and in this company we do a lot of interesting things with Java. I'm also a Java champion, Java and Rockstar, which means I kind of know a few things about Java, and we love the Groovy language. So the many things that we do in our daily work is try to come up with new ideas or new ways to be more effective, to be more productive. And this is how this talk came out to be. Because we have had real-life, real-world experiences with all the different technologies and libraries that you're going to see today. So if you have a question at any time, please let us know, and I'll try my best to answer a question. We will also have time at the end of the session, perhaps, and afterwards, there's another space if you want to have more questions. So before I actually begin with this, I have to say a disclaimer about the content that we're going to see today. All of the libraries that we're going to see today are open source. So you can safely use them in your projects. None of them use a viral license, so it's okay. And I really like to work with open source projects. Of course, there are other great libraries and projects out there in the Java ecosystem. The Java ecosystem is huge. It also has commercial products, but I'm only going to talk about open source. So my goal, and hopefully I'll be able to accomplish, is that you leave this room feeling like this. At least you will give it a try to one of the libraries that we're going to see today. So here's the challenge that I have for you. The challenge is to write a REST-based application in Java where the components must be as small and reusable as possible. We also will not like to write a lot of boilerplate code or verbose code. Like if we're using POJOs, getters and setters, they are so last century. We don't want to use them. We don't want to write them manually. And of course, this being a well-behaved application, we would like it to be fully testable. So these are our constraints. This is the challenge that we have to do. In terms of the REST-based API, I have chosen the GitHub REST API. Why? Because it's well known, it is well documented, and is easily readable. That's the link to the API in case that you ever want to just read it and see what's going on behind it. And for now, of the many different operations that you can do in the GitHub API, we're going to concentrate only on how we can query repositories given an organization or a username. You can also publish repositories, query pull requests, issue pull requests, do something with the users. The GitHub API is huge, so we're only going to concentrate in one thing. Here's how you query a repository using the REST-based API. You issue a REST call to that URL. Well, no, actually, that's the documentation for the repositories block, and you issue a query using that format. So it's just what is it? This thing? It's a get. Oh, this is not a pointer anyway. Get organizations, then use any name for the organization, and then pass repos, and you will get as a result a JSON payload that looks like this one. Actually, you get much more information out of that payload. That's what I just cut down these things. We are only interested in a few properties coming from that JSON payload. And that will constrain how we're going to do the mapping later down the road. I'm going to show how we're going to do this. So, in order to write an application to be able to do this thing, I will say that given that it's 2016, it's hardly the case that anybody will build an application without any sort of dependency injection mechanism. It doesn't matter which library you pick, it's very likely that you already have some sort of dependency injection. So we're going to use it as well. We definitely need to create an HTTP client of some sort and issue a REST call, getters, and parse the payload. Is most likely going to be JSON, it could be XML. We don't want to write that boilerplate code, and they would definitely need to handle concurrency. Because the application that I'm going to showcase is JavaFX, it's a desktop application. It doesn't have to be, but it makes it much easier for an example. All of the code, or most of the code that you're going to see today, you can also apply to the server side. I'm kind of a weird guy because I still love desktop Java. I know it has a future, there's a niche. But if you guys are writing server applications, that's okay. So, the whole code that you're going to see today is available at that URL. Everything is open source. There are 5 different variations of the application given the different set of libraries that we're going to see today. So you are free to study and read and clone the repository if you want to. You'll also have the slides later, so don't worry if I scroll very quickly to the links. So the first thing that we're going to see is dependency injection. Now, does anybody here does not know what JSR 330 is? Or @inject? See, that's what I was telling you. Most of you know what dependency injection is. Basically, what we do is we define a type. For now, I haven't decided which is going to be the return type. Why? Because that will come later, but this could be any kind of interface, any kind of concrete class. What we want is to create an instance of this thing and then supply it to some other component that is going to consume its API. So this is how we do it. This is one way. In my little application, I have defined and decided the behavior is separated within the different kind of components that you have. There is a model that sits between a view and a controller. So here we're looking at the controller. So basically what we're doing is we're injecting a couple of collaborators in the controller. That will be the model and the GitHub API object, and then just issue calls on that thing, and we'll see what happens. In order to assemble this class or these instances, we need the dependency injection container. I have selected Google Juice because it's the smaller one that is production grade and is the reference implementation of JSR 330. There are many ways that you can bootstrap an application using Juice. The interesting thing is that you have a programmatic API for defining the different bindings. So the first binding that we see there, we have a source type whose name is GitHub, and the target type is GitHub implementation, and we want to bind those 2 types. So whenever someone says, I need an instance of a GitHub type, you're going to give me an instance of GitHub implementation. And it so happens that this instance is going to be stored in the singleton scope. So you only get one single instance. But you can also get instances that are in prototype scope or any other kind of scope, as a matter of fact. So the scopes in Juice are extensible. And there are other kind of bindings that you can define. For example, the last one using the provider is kind of like a lazy binding. The actual value that is bound to the type, in this case GitHub API class, is not yet known until the first time someone requests it. This is good in case that you want this particular type, the GitHub API provider, to customize for the instance that is going to be returned. So if you need to call additional setters or, I don't know, allocate a different resources before giving back the instance, this is how you do it. The nice advantages of using Juice is, again, is because it is the implementation of JSR 330. It can provide lazy evaluated values, as we saw on the providers. It has actually 5 different types of bindings that you can apply. We saw only 3 of them. And it has a very extensible life cycle. If you happen to use Google Juice, then you have an added bonus, because one of the dependencies of Juice is Google Guava. Google Guava delivers additional collections that are not found in the standard Java library. For example, ByMap. If you ever had the need to, given that a key, you need to find a value, then you got a map. But given a value, if you ever want to find the key, this is exactly what this kind of a structure gives you. If you sometimes have a key and have a different set of values attached to that one, we usually use a list or a set or some kind of collection. But we have to manually handle or manage the list, so we have to know if the list or collection is empty or is null, so we have to create it and attach it. Well, Multimap does this for us out of the box. We don't have to do it. We just do key, value, that's it. It has additional utility classes for dealing with collections and stream and cache and reflection, so it's a bit more than that. And if you happen to be still stuck in JDK 6 or JDK 7, you still have access to some functional programming constructs. But if you're already using Java 8, then I would say that most of these functional constructs are not really needed because they already come baked into the JDK 8. Does anybody here is using JDK 8 or Java 8 in production already? Okay, almost half of you. That's good. If you haven't made the switch yet to Java 8, please do it soon because next year, hopefully, we're going to get Java 9, so you'll be lagging one release behind. If Google Juice is not what is your cup of tea, there are other options for doing dependency injection. The other well-known library out there is the Spring Framework. And there are many, many projects related to the Spring Framework. I'm just going to talk about the Spring Core. This is the only thing. The Spring Core gives you dependency injection container, but gives you more. So besides supporting JSR 330 as Juice does, it also gives you additional assertions, it gives you internationalization support, gives you JDBC and JPA support, JMX, validation, even testing support, everything just baked into. So if it were up to me, I will definitely be using more Spring Framework than Google Juice, but hey, one of the versions in the GitHub repository that you have access to uses a Spring instead of Juice to showcase what's the difference within one another. So far, so good? Okay? Perfect. So now let's get started. We want to reduce the boilerplate code. Many of these frameworks, or the popular frameworks out there, rely on you writing plain Java objects or POJOs. So for this, we know it by heart that we have to use getters and setters. I know that we can tell our IDE to generate getters and setters, but in my mind, auto-generated source code like the one that the IDEs generate gets outdated immediately just after you just generate it. And now it's up to you to handle the code that was generated by the machine. You are no longer in charge. You are the one that is actually keeping tabs on everything. I prefer to have the tools generate the code on the fly. In this case, generate bytecode instead of generating source code. There so happens to be one tool that we can choose from, and that tool is known as Lombok. Project Lombok hooks into a facility that is available in JDK 6 called the Annotation Processing Tool, or APT for short. What it does is that while during the compilation phase, it can identify certain annotations. These are the hook points. And given an annotation, it can instruct the compiler to generate additional bytecode. So what we're doing in this particular class with the addData annotation, we're instructing the compiler to generate getters and setters for each field. And we're also instructing the compiler to generate suitable constructors and equals and hashcode implementation. So this POJO is a well-behaved POJO. And the only thing that you need to do is add one annotation. It's as easy as that. The source code stays very, very short and concise. The other thing that we're doing here is we're applying another project called Jackson. Jackson is the project that we're going to use to map from JSON payload into a Java object. And remember when I showed that the JSON payload could have many, many different properties, but we only care about a small subset. Well, this is exactly the subset that we only care about. It's just about 4 properties. So in order to avoid Jackson to fail when it tries to map from the JSON payload into a Java object because it hasn't found mappings for all properties, we add one additional annotation, is that JSON ignore properties. So any unknown properties, which means properties not found in the Java code, get simply ignored. So now we're just happy. If we want to provide support for an additional property, what do? We just add a new field declaration. And data annotation and the JSON ignore properties will do all the magic for us. There's no need to maintain getters and setters. Here's another thing that we can do with Lombok. If you fancy to use the Fluent interface design or the builder pattern, then just annotate a method, like a static method. You can also annotate the class. There are various ways that you can apply the builder annotation. What this thing will allow you to do is create a new instance in a way saying repository.builder, that gives you a builder instance, and on that you call methods such as name with any parameters, full name parameters, and at the end you attach .build, and that will fully create the instance for you. What is great about Lombok, Builder, and the other annotations is that it's also aware on additional annotations such as non-null and nullable. So it will do the proper validation. If you try to supply a value for a parameter that has been annotated with non-null, then it will tell you, you cannot do this, and of course it will fail at runtime. Here's another usage of Lombok. We will use this new instance event in the application. You can see it in the source code. And what this thing is telling you is that it will also generate a well-behaved POJO, but this one is showing you the case of inheritance. What this annotation, the equals and hash code, is doing is configure further how the equals and hash code implementation method should be. In this case, it's saying, I'm going to supply hash code for new instance event, but I'm also going to call first the hash code of my superclass. In this case, it will be the application event. If it happens to have one that is custom, it will call it. If not, it's going to call the default hash code method. So the advantages of using Lombok is that we reduce all the boilerplate code that we had to put in our source code, and we just leave it to the compiler to generate the real bytecode. It relies on the annotation processing tool, which means that if you are using an IDE, then there is one additional step that you need to configure. If you're using NetBeans, you don't need to configure anything. The APT is enabled by default. If you're using IntelliJ, you just need to check one mark in your project saying, I want annotation processing to be enabled. And if you're using Eclipse, you have to manually find every single library in the class path that provides a processor. And sadly to say that the people that are using Eclipse have the harder time to use annotation processing tool. There are many transformations available by default on Lombok, so you don't have to write a transformation such as add data or add builder. As a matter of fact, writing a transformation is not for the faint of heart. I think that for other people that I can currently see at this room, I think that Charlie will be the only one that can deal with bytecode instructions, because you must target a specific compiler. You must target the Eclipse compiler or the Java-C compiler or any other compiler. So it's only a handful of people that will need to write transformations, and we all can benefit by just consuming the transformations. Okay, let's get into the behavior. Now that we know how to write POJOs, let's put some behavior in it. And once we are writing applications, sometimes we want to monitor how this thing is doing. When we are beginning, how many of you are currently still in college or students? Some of you, yes. At least the things that I did when I was in college, when I wanted to debug something, was litter my code with printouts. It's the quickest and easiest way to debug code, right? Yeah, and then we forget to leave out those printouts. The next thing that we can do is add logging statements. And there are many different logging frameworks out there. All of them are wrong. All of them have issues. But the one that has less issues is SLF4J. It has two main advantages. It provides a variable args method for all the logging statements, so you don't have to pay the price of constructing a huge string and then say, oh, is this logging label enabled? No. Okay, I just wasted time creating the string. And the second thing is that it can funnel the calls from different logging frameworks into a single place. So if you're consuming a library that requires Commons logging, Apache Commons logging, or Log4j, you don't have to continue reusing those things. You can have all those calls going into a single place, SLF4j common, or in this case could be SLF4j simple, and trigger or configure the different levels for all those APIs with just one single API. So this, I say, is much better. All right. Question for you. How many options out there to build an HTTP client in Java? How many ways are there to build a REST client in Java? Actually, there are many. How many ways are actually there to write an HTTP2 client in Java? Not that many. So if you have seen Apache HTTP client before, good, but let me tell you that OK HTTP is a much better simplified API, and it also supports HTTP too. So in order to create an HTTP client that can talk to any kind of web-based API, you can do it in this way. You create an HTTP client object, then create a request object, configure it with parameters, with headers, whatever is needed, then issue a call on the client supplying the request, and then you get a response. And based on the response, you can query the status message, you can query the body, you can query the headers, you can do anything you want. In this case, we're assuming that the response may be some kind of textual representation, could be plain text, JSON, XML, something else. We just return that thing as a big string. So the advantages, again, of HTTP is that it's ready for HTTP and HTTP2. Going forward, this is something that everybody should take care of. It's very extensible via configuration classes, and you will see that in a moment in the code. And finally, the HTTP lifecycle can be decorated via interceptor. That means that you can react to concerns such as authentication. You can change additional headers into the request, or you can process headers of the response separate from your actual logic. I'm looking at some quizzical views from you guys because I'm talking about an application. I haven't shown what the application does, right? Should have started with that one. So let me show you the application as it is. Let's go into the third version of the application. Let's run it. There it is. Here's the application. So if I enter the name of a repository here, it will query all the different repositories. And it's actually, the GitHub API will return 30 elements per page. So it has a paginated result. So this application takes care of paginated results. So let's say if I say the Griffin organization and load everything, if the network is holding, perfect. So 245 elements, perfect. Or if I give less elements, as I said, 30 elements per page, let's say, what happens if I say only 55 elements? Yeah, it loads everything. And being JavaFX and all the stuff, I can be fancy, and these entries are actually sorted on the spot as pages that are being processed. That's quite cool. Anyway, let's go back to the slides. And now you have seen what is a target. Now you know we're dealing with HTTP, and what you may be thinking, okay, good. Now we have established that, but how do we ensure that we have the correct REST behavior? So it's one thing to deal with lower level HTTP concerns, status message, request, header, response, but in reality, what we want is to deal with objects. The object that we saw earlier, the repository object, this is our POJO. We care about supplying a name for an organization and get it back some kind of collection of repositories. We cannot do that with plain HTTP. We also, anytime that we are creating a REST client, we have to deal with the HTTP errors in a standard way. So it doesn't make sense to repeat ourselves over and over and over again. I'm happy to say there is a great library called Retrofit that allows you to do the following thing. You define an annotation, you define an interface. It has to start with an interface. And you can supply any names you want and annotate parameters using the Retrofit annotations. Return a value that has to be of type call. This is also a Retrofit type. And inside it could be a list of something or collection of something, or it could be the something directly. It could be just a plain POJO. And notice that this method has an additional annotation called get with a URL parameter. This is exactly the URL that we need to call into the GitHub API. And there is another call right here that takes an URL object. This is how we're going to do pagination. The next step will be that now that we have the interface, then we need to create the HTTP client itself. And here we use a builder provided by Retrofit. What is actually happening here is that Retrofit, this builder, is going to create an HTTP client for you using OK HTTP. And this knows exactly how the GET call should be issued, how the parameters should be passed to the GET call, how the response should be parsed if it's successful. so that you get automatically a list of repositories and you didn't have to do anything at all with JSON mapping and nothing else. So once you have created the proxy, just making usage of that proxy is just like making usage of any other regular Java object, just like that. So the advantages is that it wraps REST calls using Java interfaces. You just have to deal with Java. It is extensible also via factories, and it relies on OK HTTP. So it's a smaller footprint in terms of usage, but it's also very, very useful, and HTTP2 ready. All right. But as we showed earlier, the application being an UI application, there is one golden rule that we should not break when writing UI applications, and that is everything that is UI-based, that means changing the value of a text field, or changing the color, changing properties of widgets or visual elements, must happen inside the UI thread, whichever thread it may be. Everything else, such as a network call, a database call, or any kind of computation, should happen outside of the UI thread. So how do we make this happen? How do we make sure that our UI code is working correctly and our network code does not interfere with the painting of the UI? Well, there are different options, but the one that I want to showcase today is something that we learned from the JavaScript community. They came up with this idea called promises. In a promise, you supply a callback that is the action. This is the thing that is going to create the data. And this thing is going to run asynchronously to the current execution path. Well, in JavaScript, you only are single thread, so that's kind of easy, I suppose. Anyway, you have something that is running in a different thread, and when this thing completes, then you also attach another, well, you have already attached a callback to let you know, hey, here's the result. Or this thing failed, and they will tell you, I couldn't do this, but here's the failure, so maybe you can recover in some way. We have promises in Java, thanks to this project called JDefer. It is as very simple as doing this. Remember when I showed earlier that I didn't want to put the type? Well, here's the final type of that GitHub API interface. What we have here is a promise that takes three generic arguments. The first argument is the return type. So this tells me I'm going to get as a result a collection of repository objects. The second type is what kind of errors I can expect from this promise. JDefer can throw any kind of type, not just exception, not just trouble. And if the promise or the task that is running in the background happens to publish intermediate results, then the third type that we see there, in this case void, will be the type of those results. In this case, this one does not publish any intermediate results. How do we make use of this one? Let's go back into a specific implementation of the GitHub API. Again, we're using injection for the other collaborators this API may require. And then we use this thing. This is how we create the promise itself, the task. I could have used inner classes if you are stuck in JDK 6 or JDK 7, but if you are using JDK 8, then we can use lambdas. So in this lambda, this object right here, this API object, remember, this is the Retrofit REST client. I'm just issuing a call to the network on a background thread, get a response, and then if the response is successful, then I supply all the content because it's already translated into a list of repositories. But if it's not, it's going to fail with an exception. And then, how do I consume this promise? This is the body of the controller back again that consumes the promise. Here, it obtains a reference to that promise by calling the method right there. And then if there happens to be any progress, it will call this method reference or attach any elements to a list. If there happens to be a failure, in this case, it's just going to print out into the console. And regardless of if it was a successful completion or if it failed to obtain all the results, we want this callback to be issued. In this case, showcase that some state had changed. So that state is actually, if we go back to the application, you will notice that the cancel button is disabled. So while this thing is running, you see the state change there, right? So once this thing is finished, by changing the state to ready, the load button is enabled again. So this is basically what we're doing with this always callback. Regardless of failure or success, we want to enable back that particular button. So the advantage of the JDefer again is that it delivers a concept of promises, very useful. Promises can be chained one after another. It's Java friendly, but it's only useful if the task at hand requires a one-shot execution and you only need one set of results. This is okay while we have a single page of results, but as we saw, we need to paginate different results, right? You could actually write some kind of pagination support with JDefer, but it would be better if we switch to a different construct. In this case, if we switch to reactive programming. It's time to embrace the new paradigm. It's been close to 3 years now since we got this idea of reactive programming and a new specification called reactive streams and different libraries implementing the specification and in different languages as well. But the concept of reactive programming is really nothing new. It's just events and streams like we did in the past in desktop programming. One of the many libraries that you found out there, but this one is the most popular, I would say, for now, is RxJava, written by the guys at Netflix. What we do in this case, instead of getting a collection of objects, what we get, a collection of repositories, what we get is something called an observable. This object is kind of like a lazy object that can calculate results as they go. You can actually create a pipeline of data transformations. So what is actually happening here, this observable object, let's start with the beginning. We obtain a reference to that observable object. That does not yet consume the data from the network. We're just creating the pipeline. If we happen to have a limit, that's the text field, how many elements I want to get back from the result, then I decorate the observable using the take operator. This creates a new observable that has that particular limit. So we are concatenating operators on the observable. This is similar to what we do in Java 8 when we apply additional operations on a stream. But as we do these operations, the stream doesn't consume the data. It's until it reaches a terminal operator or a terminal operation when the data is pulled from the stream, right? This is exactly what happens in the observable. It's until we subscribe that we're going to pull in the data from the observable. So when we subscribe, any data that is coming in is a repository by repository, so each element as it gets translated from JSON, then we're going to add it to our collection. And if we happen to get an error, then we're just going to print out into the console again. It is possible to use both Retrofit and RxJava together. There is an extension to Retrofit, and this is thanks because Retrofit is extensible via factories. So once you have configured the factory, you can change the interface that we defined before. Remember that this used to be just call. Now it's an observable that returns a response that returns the real type that I want. It's a little bit of boxes and boxes of generic types, but trust me, there is a reason to do this. Because if we need to find out that there is a next page, how do we do it? We have to go back into the GitHub API definition, and we see that in the headers of the response, there is one particular header called link. And in the link, we can find if there is a next page or not. Before we get into that particular piece of code, this is how you create back again the Retrofit client. And notice that the only thing that we added now is an additional factory, the one that knows how to translate values from RxJava into what we need to do. So how we do the pagination? This is the gist of the code. We just supply two lambdas to an additional method that we control, in this case paginated observable. One lambda calls the first REST call, the one that takes the name of the organization, and the second lambda takes the URL that is supplied as an argument. So how do we extract that information? Well, the whole code fits in one slide. I'm happy for that. Actually, we have two different methods because we're applying recursion. Basically, what we do is every page that we query is going to give us a list of repositories. And we want each page to be seen as a stream or as actually a single observable of values. So we need to flat map each list into a single observable. That's exactly what's happening here with the flat map. And for each page, what we want is also to concatenate all the values that we get. So that's what we do here, the concatenate with that observable. So in the end, after we do all these operations, we are consuming simply an observable of repository is no longer an observable of collection of repository. This is exactly what we want. The interesting thing about RxJava is that it implements the observable pattern, and it delivers a dozen of operations. So if some of these operations start to be a bit confusing to you, don't worry. There's excellent documentation with diagrams telling you what does map, zip width, concat, flat map, all the different operators can do when you're dealing with different kind of data. Okay, so far so good, I suppose. Finally, I know that I showed examples when an exception occurs, we simply print out to the console. That is not really good, right? So what if we wanted to display a dialog when something went bad? I don't know if Joker, or there's even a Joker organization. Let's see. Let's query that. And if there's not it, then we're going to see an error. Hey, instead of going into the console, we pop an error. The interesting thing is that if I show you the controller code for this, let's go back. And the code, as I said, is available on GitHub. For this one is right here. And if I show you the controller code, oh, no, I want this test. We'll get into test in just a moment. And here we go. Controller. Make it bigger. What this controller is doing is, when it encounters an error, instead of printing out, it's going to publish an event into something called an event bus. And in this way, the controller has nothing to do with dialogues, has nothing to do with UI. So this whole logic can be fully tested without any UI concerns. It will be up to somebody else, some other component, to handle this event. And in the case of this application, it happens to be an utility class that relies on JavaFX, and it does this. It has an annotation coming from this project that I'm going to talk in just a moment called Ambassador, and this tells this project, this application, that whenever an event of this type, it doesn't care about the method name, it can be anything, but when this type is pushed into the event bus, then this object, this instance, is going to react to that change, and what it's going to do is pop up a dialog. So what this thing has to do also is subscribe itself to an event bus. And when this instance gets destroyed, we unsubscribe from the event bus because we are good citizens. So this is the reason why, again, we use dependency injection and use additional annotations coming from Java 7. When a new instance is created inside a dependency injection container, this type of method that is annotated with post construct will be created right away. And when the instance is about to be removed or disposed from the dependency injection container, then this other method is going to be called. And notice that the method can be private because this is just something that is kind of like an additional construction setting, or a destructor if you're coming from C++. So this project that I was telling you about, Ambassador, allows you to do precisely that. It's just a simple, very easy, configurable, lightweight event bus. And this is, so I showed you how we publish and how we consume the event. So there's nothing there to JavaFX anymore. What I like about this project is that it's much better than the alternatives. The alternative would be to use the Guava event bus, which is kind of okay, I suppose. There is one particular problem with Ambassador, is that the author is not so much active now. Actually, there was one release made to this project 2 weeks ago. But before that, it took months for the past release. There is, however, also a benchmark that can tell you why Ambassador is much faster than the alternatives. So if speed and performance is your concern, then this project is good to go. It is production ready, but if you encounter bugs or if you want to have a feature request, just be aware that that code might not be solved as quickly as you would like to. Okay, I think that's now time to switch to testing, because we have already covered pretty much everything that we need to do in terms of production code. But how do we test UI code? Do you even test UI code? Yes, because you don't write UI test. How do we test concurrency code? It's easy to test something that is not concurrent, but now that we have introduced concurrency and asynchronous threads, that's going to be a little bit of a problem, right? Well, not exactly. To begin with, I suppose that most of you use JUnit. Anybody here use ESS TestNG? Few hands. Good. So I'm going to stick with JUnit, but there are some interesting features found in TestNG that JUnit can simply do. One of them used to be test parameterization. JUnit 4 allows you to parameterize a test case, but only a single method. Why? Because the method has to take, you can define certain annotations to parameterize the test method, but any other test method available in the same test case has to have the same number of arguments in the same order with the same types. So essentially, if you need different parameterizations, you need different test cases. But if you use JUnit params, then you can have a different set of annotations that can allow you to have different test methods in the same test case with different arguments and parameters, different order, different cardinality, different types, and also different data providers. So this simple test case that we're showing here, we are looking at the data provider inline in the annotation, but you can also supply the method, a method name, or even a class that is the data provider itself. This thing, what it's doing is making sure that this object is a very basic trivial unit-based test case, that if we call that method, then we get that output, using Hamcrest matcher also. Good. The next stage would be if we are into unit testing and we have a component that requires different collaborators. If we stick to what TDD should do, then we need to provide fake collaborators, because only the class under test is the one that is the thing that we care about. Everything else should be somehow easy and should not be coming from production anyway. So for this, there are many options, but I will say that Mockito is perhaps the best option that you can find out there. Here's a test case, a real test case from the application, and this one, this is from a different kind of application, but it's kind of the same. We have a sample controller object that has a model as a collaborator and has a service also as a collaborator, but we want to fake out the service. So we set up the expectations using a DSL from Mockito. This is just a static method. I like to use a lot of static inputs. So when this proxy, which is the service that we have created with the mock, we invoke the real method with some input, and it's going to match that input. When that happens, then we want to return certain output. This is the most basic kind of expectation that you can set, but there are other custom expectations that you can also set. Once you do, you go into the stimuli block and then issue the real thing. This is the class under test, the controller. And then finally, we verify that the controller did the right thing, but also verify that the mock, or in this case the stop, did the right thing, which means I expect the service method say hello input to be called only once. If the controller never called the service, never called this method say hello with that input, then the test case is going to fail. And this is what we want to do. So what I like about Mockito is that it provides a fluid DSL. It gives access to a stop. Stops are plain proxies that deliver a predefined result, just like we did. Or mocks, where you can verify cardinality and order of invocation. Or even spies, which are real objects on which you can fake out certain methods. Sometimes this is a good thing. You can mock interfaces, you can mock abstract classes, and you can mock concrete classes. And as a matter of fact, Mockito makes use of another interesting library, low-level library, I would say, called ByteBuddy. The author of ByteBuddy is here at the conference, Rafael Winterhalter, and he actually has a talk right after this one on one of the other rooms. So if you want to know more about Java Lang Reflect Proxy and creating dynamic code on the fly, definitely catch Rafael on his next talk. We said earlier that we're using Juice for our application, and we have only seen again also Mockito. Will it be cool if we were able to inject types into a test case? Just like we do with Juice in production code, would it be great if we can inject collaborators in a test case? This will simplify setting up the test case. Well, yes, we can. There's a project called Yukito. It's the union of Unit, Juice, and Mockito. What's great about Yukito is that notice that you can do inject on the test case, but also you can supply additional types to a method. And this type happens to be a Mockito mock. So, if you do not supply a binding for a type in your test case, it's going to be mocked automatically for you. And notice that this service, you can verify it again. You can set the expectation exactly the same way as we did before. That's pretty good. If you're feeling adventurous and you want to stretch out into different JVM languages, not just Java, does anybody here use another JVM language besides Java? Let's say some hands. JRuby. Come on, Charlie. JRuby. Groovy. Scala, Clojure, just a few hands for each one of these. Well, Spock you can think of Spock as a testing DSL. You write the code in Groovy, but notice how the code looks like. This is one of the possible ways that you can create almost the same behavior as Mockito. As a matter of fact, the creator of Spock used to work in the same company as the creator of Mockito, and they share a lot of information with one another. So what we're doing here is that, what is that? That's supposed to be the method name, but it's a string. Weird. So this is one thing that Groovy allows you to do, that the JVM also allows you to do, is you can put any character as the method name. Java, the language, is the one that says, no, you cannot have spaces as a method name. No, you cannot have this character on a method name. But Groovy lets you do that. So what is going to happen is that when we iterate over the different elements that this test case has, so actually this test case says, given I'm setting some mock, when I exercise the controller, then I expect something to happen. Notice that there's an implicit assertion. And this type, what is this type? We expect that to be a string. What are we doing there? Equals equals. Is that a good thing or a bad thing? How do we compare strings in Java? Using the equals method, right? If we use the equals operator, then we get a slap on the wrist, isn't it? Well, the good thing in Groovy is that this equals equals operator is overloaded. There is operator overloading in Groovy. So this actually calls the equals method for you. But it looks very much better to the eyes, right? And then finally, in this word block, what we're saying is, by the way, the values of input and output are going to be empty, string, and test for 2 iterations, and howdy stranger and hello test for the other iteration. So this test method is going to be executed twice, just like we did with JUnit params. So these are the advantages of using a Spock. Perfect. But yet, we haven't covered how we actually test out concurrency. We're just dealing with parameterization and making our test look nicer, right? We still have the problem of how we test concurrency. For that, I can show a utility. And the real example that I want to show is this one. This is the real code from the application that you can find on the repository. So, given that we create a collection of repositories, this is just test data. When we issue this call on the GitHub object, this will be coming from Mockito. When we issue that call, we return an observable with that list. That means, here's the data. Now you got an observable that contains the data. And how will you consume it? We consume it in the controller. But given that this thing is happening in a background thread,
we need the test case to wait till certain condition is true. For that, we use this project called awaitility. So the important line is right here. We will tell this test case, wait for at most 2 seconds. If the operation does not finish within 2 seconds, the test case is going to fail. And we wait until this condition holds true. We use method references to query a certain object, and we use a handcrest matcher to figure out if that particular state is in the right value or not. Once this happens, then the test case can continue. So if these sessions are executed, that means that we were able to obtain all the values within the 2-second timeout. So our utility contains a DSL for testing multi-threaded code. Is Java 8 friendly, but it also contains extensions for Groovy and Scala if you want to use Groovy closures or Scala functions. You can customize conditions using handcrest matchers, and you can create your own conditions very easily. Here's another example. This is the wrong title. This should not be a utility. This should be WireMock. Because we are testing a REST API. Somehow, we would like to test out the client code without hitting the real GitHub API server, right? Because we have rate limits. Because if we want to break out of those rate limits, we have to have authentication. But we can also, when in the case of GitHub, it's fine. But if we are testing our own servers, are we certain that the server we want to test out is alive and is ready at the right state when we are running the test? This is hardly the case. What we need to set up is a fake server. So the project that we need to be talking about is not a utility, it's actually called WireMock. Let me show you an example of that. The code is right here. Let's go into testing. Yeah, source test Java. Network is taking, see, I cannot rely on network. If I were running the server somewhere else, then my test will probably fail. But if I run the test while I'm trying to make this thing work, notice that at some point a window will appear. That's okay. This is a real integration test, and this is hitting a fake HTTP server. Let's look at the code here. It will be better. It will be faster. So let's search for it's in test, and here's my functional test. Make it bigger. Come on. And here we go. Bigger, bigger, no smaller. Here's my functional test. Using WireMock, using another feature from JUnit called rules, we're setting up a fake server on this port 8080. And then we say, if you receive a GET query that matches this pattern, then we're going to respond. We're going to supply a response with a 200 status code, so that's good. With this content type and the following body, which is actually a JSON payload of all the repositories transformed using Jackson. And then just issue UI test code. This is using another project called TestFX. So if you're into JavaFX development, you should know about TestFX. So it's just like WebDriver or Selenium, but for JavaFX. So this is basically what we're doing. Click on objects to figure out if we got the archive information, and finally verify if a list contains the right amount of values. This is another one when we're testing the failure path, which is given this URL regular expression, if you will, or pattern actually, we respond with a 500 and some error message. So now we expect the error window to appear. And that's basically what we do with WireMock. It also contains a DSL for defining how the responses and the requests should be matched. And it also supports record and playback mode. So it's pretty cool. This is all that I have for you. As I remember, all that I showed today is open source. You can download the example code and study and use it as long as you comply with the license. And if you are not into open source, at least if you are not you're already consuming open source. But if you are not producing open source, don't worry, it's very easy to get started. The first thing you do is that you create a GitHub account if you don't have one, and then go into one of the projects that you use most of your day, and then just start on it and say to the developer, thank you for doing this project because it's helping me. The next thing that you can do is that if you find a bug, if you find a problem, just create a simple bug report, and this helps a lot of people, trust me. The last thing that you can do is actually supply a code patch to fix the problem. So with this, thank you very much, and if you have any questions, I'll be very happy to take them. Are there any questions? Oh, there's one over there.
Does the code that Lombok generates have any runtime dependencies on Lombok, or is it all isolated?
That is a good question. No, all the code that Lombok generates is compile time only. Even the annotations get removed from the generated bytecode, so the Lombok jar should not be part of the runtime dependencies of any project at all.